X-rays. Let's start with some properties of X-rays and what are they. So first off, a definition: they're high frequency electromagnetic radiation. Let's take a look at the spectrum. Alright, so on the far right hand side of radio we should have TV waves, and between X-rays and the blue part there we should have ultraviolet. You'd remember these, or the relative position of these, with the real men in Vietnam use X-rated guns. The is T, that's TV waves. Real is R for radio. Men is M for microwaves, and so on. So the real men in Vietnam use X-rated guns. The relative positions you need to know, and you need to know that if you read from right to left, the energy of those forms of electromagnetic radiation are increasing, and so are the frequencies. So that means that X-rays have a higher energy and higher frequency when compared with TV, radio, microwave, infrared, visible and ultraviolet light. It has a lower energy and frequency than gamma rays. The wavelengths then are reversed. So the largest wavelengths are on the right, the smallest wavelengths are on the left, which means that X-rays have a smaller wavelength than TV, radio, microwave, infrared, UV and visible light. Okay, just take note there as well that X-rays are actually a range of frequencies or a range of energies or a range of wavelengths. It's not a single value. Okay, so because they have high frequencies and quite high energies, if you shine an X-ray on a substance, it can give the electrons enough energy to be removed from the atom, leaving behind an ionized atom and a free electron. And if you shine an X-ray on human skin, it can ionize the atoms in the human skin, which leads to a defect which can cause cancer. So a defect in the reproduction of your skin cells, which can cause cancer. And this is why when you're getting an X-ray from a dentist, the dentist always steps outside the office, because he doesn't want to be exposed to repeated X-ray dosages, which can cause ionization of his skin cells, which can lead to him getting cancer. Right, you'd produce X-rays in a hot cathode Coolidge tube, and how that works is X-rays strike a high density target. They're moving very quickly, and that high density target will give off X-rays. We'll deal with that in the next video. Okay, X-rays can be absorbed by some materials and pass through others. So if we think about a broken bone, if a bone is broken, there's a crack. So there's a gap between two sides of the bone. The X-rays can pass through that, but it can't pass through the bone, so it's absorbed by the bone. And that can be used to take a photograph of a bone and to identify any cracks in it. It can also be used to identify different densities in your teeth. So if your teeth are weak or they're likely to fall out or fall apart, then X-rays can pass through them. If they're very strong and very solid, X-rays can't pass through them. And we can also use that to determine the density of different pipes, or if there are cracks in pipes, or more specifically, airports use them to determine if there are micro cracks in airplanes. Because if there's a micro crack in an airplane and a plane takes off, well, that crack can become a bigger crack and a part of the airplane can fall off, causing a crash and killing people. Alright, and I said there a minute ago that X-rays are actually a range of frequencies or a range of energies. The higher frequencies can pass through denser materials. We call these hard X-rays. So these would be the frequencies that are closer to gamma rays. They're also more ionizing, so they cause more ionization of atoms, and you're more likely to get cancer from exposure to those. Softer X-rays can't pass through denser materials, so they have less penetrating power, and these would be the frequencies of X-rays that are closer to ultraviolet light. So that's the end of video 1. In video 2 we'll have a look at the Coolidge tube, or how to produce X-rays.